Right now, somewhere on this planet, a lion is lying 20 feet away from a sleeping human in a tent with no walls, no lock, no weapon stronger than a flashlight, and it does nothing. It just watches. Or it doesn't even bother watching. It walks past. This should not make sense. A sleeping human is, on paper, the single easiest meal a predator could ever ask for. No alertness, no defense, no fighting back, completely unconscious, completely vulnerable, completely still. Every instinct you have about nature tells you this is exactly the moment a predator strikes. And yet, across documented history, from African safaris to Arctic expeditions to soldiers sleeping in open jungle during wartime, there are countless recorded cases of large predators walking directly past sleeping humans, sometimes within arm's reach, and simply leaving them alone. So what is actually going on? Why would the most dangerous animals on Earth ignore the easiest prey they will ever encounter? The answer involves smell, instinct, evolutionary memory, and one deeply unsettling psychological trait that predators have evolved specifically around us. To understand why predators ignore sleeping humans, you first have to understand how predators actually decide who to attack. Most large carnivores are not opportunistic in the way we imagine. They don't simply attack whatever is nearby and vulnerable. They are calorie accountants. Every potential attack is a risk versus reward calculation running constantly in the background of their brain. A predator is assessing things like how much energy will this cost me? How likely am I to get injured? Is this prey worth the risk? And critically, does this thing behave like prey? Here's the key detail. Predators are overwhelmingly triggered by movement, fear response, and panic. Prey animals run, dart, flinch, and flee, and that fleeing motion is often what triggers the chase instinct in the first place. It's why deer freeze first, because freezing temporarily removes the visual trigger that says, chase me. A sleeping human isn't running, isn't flinching, isn't behaving like wounded or panicked prey at all. To a predator scanning the environment for signals, an unmoving body can read less like vulnerable and more like irrelevant. It simply doesn't activate the same hunting circuitry that a fleeing antelope does. This is sometimes called the stillness paradox in predator-prey research. Stillness can be both the most dangerous position, zero ability to react, and the most protective one, zero trigger to provoke. Now here's something that genuinely surprises people. A huge part of the answer comes down to scent, and not in the way you'd expect. Most large predators rely heavily on smell to assess threat and eatability, and human scent is, biologically speaking, bizarre to them. We are coded in a chemical signature unlike anything else in the natural world. Soap residues, synthetic fabrics, sunscreen, repellents, food smells, and a body odor profile shaped by a diet completely unlike that of any natural prey species. Wildlife researchers studying predator behavior near human camps have found that many large carnivores treat unfamiliar human scent with caution rather than appetite. Novel, unrecognized smells generally trigger wariness in wild animals, not hunger, because in nature, unfamiliar usually means untested, and untested is risky. There's also a documented phenomenon among researchers who study big cats and bears. Human scent has, in some recorded cases, been found to have an almost repellent effect, comparable in some studies to the deterrent effect of other large predator scent markers. In other words, we don't just fail to smell like food. To many predators, we may actually smell like something to avoid. Body shape plays an enormous role here too, and it goes back much further than most people realize. Predators have spent millions of years evolutionarily calibrated to recognize specific prey silhouettes: four-legged, horizontal, low to the ground, a particular height-to-length ratio that matches deer, antelope, zebra, and the like. Humans, even lying down, don't fully match that profile. We're oddly proportioned: long limbs, a disproportionately large head, an unfamiliar outline. Researchers studying primate and early hominid evolution have proposed that bipedalism itself, standing upright, may have offered a survival advantage specifically because it broke the expected silhouette that predators had evolved to recognize as prey. This is part of a broader theory sometimes referred to as the upright posture defense. Standing tall doesn't just make humans look bigger, which alone discourages many predators. It also disrupts the pattern matching system predators rely on to identify a target species in the first place. A sleeping human, curled up or lying flat, still carries an unusual silhouette compared to a deer or wildebeest, one that doesn't perfectly fit the mental template most predators have refined over millions of years of hunting actual prey animals. But the most powerful explanation here isn't about smell or shape at all. It's about memory, not individual memory, but something carried at the species level. We've talked before about the 2016 super predator research, where playing recordings of casual human conversation caused mountain lions, bobcats, and deer to flee faster than they did from the sound of other apex predators. That same underlying fear appears to extend even to sleeping or passive humans. Many large carnivores today, including lions, tigers, and bears, are descended from populations that have been hunted by humans for thousands of generations. Evolutionary biologists studying predator behavior around human settlements have found that this isn't something each individual animal has to learn firsthand. Caution around humans appears to be passed down behaviorally, observed and reinforced from mother to offspring generation after generation, even in populations that have had limited direct conflict with humans recently. This means a sleeping human in a tent isn't being assessed purely as food that can't run. On some level, that same animal's ancestral lineage has encoded a deep, generalized caution around anything human-shaped, human-scented, and human-sounding caution that doesn't simply switch off because the target happens to be unconscious. The risk calculation the predator runs isn't just, can I catch this? It's, is this safe to approach at all? And for many large carnivores, the answer related to humans has been no, for an extremely long evolutionary time. Of course, none of this means predators never attack sleeping humans, and the exceptions are exactly what prove how specific the calculation really is. Attacks on sleeping humans are disproportionately associated with very particular circumstances: an animal that is sick, injured, or unable to hunt normal prey, an animal that has lost its natural fear through repeated habituation to humans, often through unsecured food or garbage near camps, or genuine starvation conditions where the risk-reward calculation flips because the alternative is death anyway. Man-eating tiger cases studied in the Sundarbans region, for example, have frequently been linked to tigers with dental damage, injuries, or physical conditions that made hunting normal prey difficult or impossible, meaning the safer option of normal prey was no longer actually safer for that specific animal. This actually reinforces the core idea rather than contradicting it. Predators aren't ignoring sleeping humans because they're incapable of seeing the opportunity. They're actively avoiding it because, under standard conditions, the ancestral risk calculation still says human equals threat, even when the human in question is doing absolutely nothing. So why do predators walk past sleeping humans? It isn't mercy, and it isn't because we're hidden or lucky. It's the convergence of several things working together. Stillness that fails to trigger the chase instinct. Scent that reads as unfamiliar or even repellent. A silhouette that doesn't cleanly match the prey template millions of years of hunting built into the predator brain. And a deep, almost inherited memory that humans, even motionless ones, represent danger rather than dinner. There's something genuinely strange sitting underneath all of this. We assume safety in the wild comes from strength, weapons, or alertness. But what they actually think you are, to a strange featherless giant, and to a waterless giant, but course we never consciously do at all, simply being recognized on some ancient biological level as the wrong kind of target. The lion lying near the unlocked tent doesn't choose mercy. It's running a calculation written by millions of years of evolutionary pressure, one shaped by every human encounter its ancestors ever survived or didn't survive. We spent the earlier part of this series learning that animals fear us more than they fear each other. This is the other half of that same story, proof of just how deep that fear runs, deep enough to override even the easiest possible opportunity. If this changed how you think about sleeping under the stars, let me know in the comments. Subscribe for more research-backed deep dives into the hidden science of survival. And next week, we're looking at the one predator that never got the memo.